Hi friends, I am Palak and in this video we will cover the topic that is mesh analysis. And if you watch this video till end, that is my guarantee you can solve any example of mesh analysis. So let's start it. Now here we will consider one diagram and we want to find out the voltage that is Vx using mesh analysis. And we know very well mesh analysis is a technique based on the Kirchhoff's voltage law. So we will write the voltage drop across each and every element. So first, just let us consider how many mesh is present in this diagram. So yes, there are the three different mesh. This is mesh 1 and the current is I1. This is mesh 2, current is I2. And this is mesh 3, current is I3. And here I am just assuming the current direction, that is clockwise direction. If you want to assume it in anti-clockwise direction, that is perfectly fine. Now, based on this current I1, there is some voltage drop across this 2 ohm of resistor. So, what is the polarity of that voltage drop? So, let me explain this. See, the current direction, that is in a what? Clockwise direction. So, this end come first. So, mark positive sign here. Another end will become negative. Similarly, for this 2 ohm of resistor, see the clockwise direction. This end come first. So, plus this end come second. So, it's a minus. Now, consider the I2. See, in I2, there are the three different elements, 1 ohm, 5 ohm and 2 ohm. But already polarity is there in this 2 ohm of resistor. So, no need to apply again. So, simply we will write the polarity for the 1 ohm and this 5 ohm. See the clockwise direction. So, this end come first. So, plus this minus. Similarly, this end come first. This end minus. Now, already the polarity is there in this 2 ohm and 1 ohm. So, for this I3, only the remaining element is what? It's a 3 ohm of resistor. See this direction. Okay, it's a clockwise direction. So, this end come first. So, mark plus here and negative here. So, I hope this polarity is understood now. Now, next is, see, based on this polarity, we will write the voltage drop. So, for that, what we will consider? If the polarity is changing, that is from positive to negative, we will consider that voltage drop as a negative voltage drop. Remember this few points. Now second, if the polarity is changing from negative to positive, we will consider that voltage drop as a positive voltage drop. Now using these two facts, let's write the equation for the loop I1. See, we will start with this 2 ohm of resist, 2 volt of voltage source. See, the polarity is changing from negative to positive. That means case number 2, we will write that as a positive 2. Now, the second element, that is 2 ohm. Polarity is changing from positive to negative. First case, okay, voltage drop is minus. Now, how we can find out the voltage across the resistor? Simple, using Ohm's law. V equal to IR. The value of resistor is 2 and the current is what? Yes, this element is part of two different loops. One is I1, another is I3. So, just check the current direction. That is, I1 is entering from the positive terminal and I3 is entering from the negative terminal. So, the current is I1 minus I3. Now, the last element of this loop, that is 2 ohm. Again, see the polarity that is changing from positive to negative. So, voltage drop is negative. Value of resistor is 2. Again, that is a part of two different loops. I1 is entering from the positive terminal. I2 is negative, which is equal to 0. Now, let's open this bracket. So, 2 minus 2I1 plus 2I3 minus 2I1 plus 2I2 which is equal to 0. So let's simplify this. So what we will get? 2 equal to 4I1 minus 2I2 minus 2I3. Now let's divide this equation by the 2. So what we get? 1 equal to 2I1 minus I2 minus I3. This will become my equation number 1. Similarly, we will write the equation for the remaining loops, that is for I2 and I3. See here I have just write down 2. Why? Because it is a voltage source. So please don't make mistake like don't write it 2 into I1. You cannot multiply the voltage with the current. Okay, that is true if the resistor is there. Now for I2, there are again 3 different elements. Now let's start with this 1 ohm. So polarity is from positive to negative. First case, minus 1. I2 is entering from the positive, I3 is negative. Now 5 ohm is a part of only one loop, I2. See the polarity positive, negative. So voltage drop is negative. Resistor is 5 and I2 is entering from the positive terminal. Now for 2 ohm, polarity is changing from negative to positive. Case number 2. Voltage drop is positive. Resistor value is 2. I1 is entering from the positive terminal. I2 is entering from the negative terminal. Now let's open this. I2 minus minus plus I3 minus 5I2 plus 2I1 minus 2I2 which is equal to 0. Now let's simplify it. 2I1, then this is what? I2, 5I2, 2I2. So minus 8I2 plus I3 which is equal to 0. So this will become my equation number 2. Similarly, we will write the equation for the third loop. See here. Let's start with this 3 ohm of resistor. So polarity is changing from positive to negative, first case. Minus 3 and that is the part of only one loop. So I3 is entering from the positive terminal. Then for this 1 ohm, the polarity is changing from negative to positive. So second case. Plus 1. I2 is entering from the positive terminal, I3 is from the negative terminal. Same for the 2 ohm of resistor. Voltage drop is plus 2, current is I1 minus I3 which is equal to 0. Now let's open this. So what we get? Minus 3I3 plus I2 minus I3 plus 2I1 minus 2I3 which is equal to 0. Let's simplify it. Minus plus 2I1 plus I2 minus, here see 3 minus 4 and minus 6I3 which is equal to 0. So this will become my equation number 3. So here I have a 3 different equation 1, 2 and 3. Now we want to find out Vx if you remember. Then the Vx is simply like that. Here one resistor is there. Here what we have written, that is Vx. And here some resistor is there like this. And this is the part of the second loop I2. And here the resistor value what? It's a 5 ohm of resistor. So Vx is simply become what? Resistor value is 5 and the current value is what? It's I2. So from this 3 equation, we are interested to find out only the current I2. So no need to find out the current I1 and I3. Alright. Now, how we can find out the I2? Then write down the matrix. Then here, see how we can write down the matrix. First column represent the I1, second is I2, third is I3. So in a first column, write down the coefficient of I1, 2, 2 and 2. Now second column is a coefficient of I2. So here in the first equation, coefficient is -1, second -8 +1. Now third is -1 +1 and -6. Then here write down I1, I2, I3, and which is equal to, see this 3 value, that is 1, 0 and 0. Now what we will do? We will find out this delta, determinant. So how we can find out this determinant? Using matrix, that is determinant that equal to 2, then multiply this 2, that is plus 48, minus this 2, that is -1, minus minus plus 1, because second element always you have to consider minus. Then just element this row and column. So -6 and 2, that is -12, -2. Then -1. Now element this row and column. So what we get? 2 minus plus 16. So determinant will be 2 into 47 minus 14 and minus 18. If you solve this, then you will get 62. Now, for I2, what we can write down? See, in a place of this column, why I have choose the second column? Then if you remember, the first column is I1, second column is for I2, third column is for I3. So what we will do? We will replace this second column with 1, 0, 0 and write down again 2, 2, 2. Then second column will become 1, 0, 0. Third is as it is, -1, 1, -6 divided by determinant. So here same procedure, 2, 0 minus 0, -1, then it's a -12, -2. Last one is -1, 0 minus 0 divided by 62. So what we get here? That is 2. Then here it is 0. Then here it is what? This is -14. Minus plus 14. Then 0 divided by 62. Which is equal to 14 divided by 62 ampere, which is the answer of current I2. Now, as I said, see, this is the diagram and we are interested to find out the voltage drop, that is Vx, like this voltage drop. This is the voltage drop. So, the value of resistor is 5. And the current is what? Only I2. So the value is what? It's a 5I2. And we have already the value of I2, which is what? 14 divided by 62. Now simply we will multiply the 14 divided by 62 with the 5 volt. So Vx will be 14 divided by 62 multiplied by 5, which is equal to 1.129 volt, which is almost equal to 1.3 volt. So this is how you can find out the Vx using mesh analysis. If you have any doubt in this example or any example related to mesh analysis, then write down to me. My email ID is palak.vadadia@gmail.com. Please like and subscribe my channel to watch the more video related to circuits and network. Thank you.